Welcome back. In this video lecture, we are going to discuss the diazotization reaction. Before going into the detailed reaction mechanism, we see the overview of diazotization reaction. So here we took a primary amine, so that this R group may be aliphatic or aromatic. So it reacts with the sodium nitrite. So please understand that NaNO2 means nitrite, NO3 means nitrate. Okay, so please be careful. This is nitrite. React with in the presence of acidic condition like HCl, and the temperature should be 0 to 5 degrees Celsius. Okay, so this is must, and we get the diazonium salt. Okay, so this is RN2Cl. So this is called as a diazotization reaction. Okay, now start the reaction mechanism. So first, what will happen is this sodium nitrite, this is the structure of sodium nitrite, and it react with HCl and it generate the nitrous acid inside the reaction. So we called this is an in situ reaction or in situ generated. The nitrous acid is generated in situ, and this nitrous acid is going to react with further acidic medium. So this lone pair electron of this oxygen attacks this proton and forms like this. Okay, now this oxygen will get the positive charge and it became a good leaving group. So water molecule and forms this is nitrosonium ion, and now this electrophile has been generated. Before completing that, please check the octet of this nitrogen. Now this nitrogen is having 6. You see, to complete that octet, that lone pair electron of that oxygen donates it to maintain octet for both oxygen and nitrogen. You see, now both the atoms are having octet, but now the oxygen is having the positive charge. You see, now this is an electrophile. Now this electrophile is going to attacked by the amine NH2. Now you see, like this, the lone pair electron of this nitrogen attack this nitrogen of this nitrosonium ion, and this the pi electron is getting delocalized. So we will get like this. Okay, now this nitrogen will get positive charge and there is a bond formation. That's all. Okay, like this. Now this hydrogen will donate its electron to regain this electron or lone pair electron for the nitrogen, like this. Okay, or it gets stabilized in simple meaning. So like this it formed. Now this step is very important. So this getting rearranged and form like this. We will get like this one. So this product is called as a diazo hydroxide. Okay, so this diazo hydroxide, diazo means what? Di means 2, azo means nitrogen. That's why we call this diazo hydroxide intermediate, and this again further reacted with the acidic medium, it's get protonated, and finally it like this. Now the water molecule will get cleaved. Okay, minus H2O, so we get like this. Now this nitrogen will get positive charge. Okay, so now you see the lone pair electron will donate here because this nitrogen is not having octet, so they will get like this. Now this will be the positive charge. Okay, now please, now we reached the final stage, and this is a very important place. Please listen carefully. When the R group is an aliphatic group or alkyl group, so this at this stage, this is actually a diazonium salt. This is a diazonium. This is aliphatic, a diazonium. Now this is highly unstable. This is unstable when the R is alkyl. Okay, and it gives carbocation. Okay, if it is aromatic, then that will be more stable. That we will discuss later. Now you see, we take this R is an butyl. I take this R is a butyl. If you carry out the diazotization reaction, this NaNO2 HCl and 0 to 5 degrees Celsius, so what will happen? This get cleaved and we will get a R plus. That similarly we will get this carbocation butyl. Okay, so we will get the butyl. This is CH2. Understand it? This is a butyl carbocation we get. And this butyl carbocation may rearrange. You see, this is the primary carbocation. Understand it? This is a primary carbocation. And it may rearrange like this. This is a secondary carbocation. This primary carbocation may get attacked by this one HCl or this one in the aqueous condition. We will get some substitution product. You see, like this. See, we may get like this or like this. Okay, here after the rearrangement also we can get by this way. So this also possible. Okay, we will get a mixture of products. At the same time, this one will also undergo a elimination. Okay, these are the substitution products. Okay, these are the substitution products. So this may undergo elimination reaction also. So to get like this, and this will also undergo elimination like this. Okay, so if you take this aliphatic primary amine, when is that this is an R group, so we will get a carbocation. That carbocation will get rearranged and we will get a different products, a substitution and elimination in that various rearranged products is possible. Okay, so this is the one of the disadvantage for the aliphatic primary amine. Okay, now what will happen for the aromatic primary amine? In the similar way, it will form like this. like this. Now this will be the positive charge. So this positive charge is dispersed throughout a molecule by the resonance. You see, now this will undergo like this. You know how to draw the resonance structures. So you have to shift the pi electrons or rotate them in the sequential way like this, okay. Now this nitrogen will get a negative charge and this will also get positive charge. Again you can rotate like this, so you will get a various resonance structures like this, like this. Again you can rotate like this. So by this way the positive charges completely delocalized or spread over the molecule. That's why this aryl diazonium salts are more stable than the aliphatic one. Okay, so these are stable. Okay, and this is more useful in the synthesis of various intermediates that we will discuss in the forthcoming classes. I hope you understand this reaction. I am just summarizing it. This is the sodium nitrite. In the acidic condition it generated nitrous acid. The nitrous acid further reacted with acidic medium. It forms a nitrosonium ion. That nitrosonium ion is getting reacted with amine. So it generates this type of a diazonium salt. If it is an aliphatic, that is highly unstable and it forms carbocation. That carbocation may get rearranged, that we already learned. So that before rearrangement also we will get undergo, these are the elimination products. These are the elimination to get the alkenes, and if it is substitution we will get the substitution products. Okay, and later we discussed this one aryl diazonium salts. So these are highly stable than the aliphatic one. I hope you understand this video lecture. Kindly subscribe and share it if this video lecture useful. Thank you.